Hello everybody and welcome. My name is David Gray. I'm Head of Marketing here at Extherm by Eaton. Today's session is dedicated to industry standards and best practices for continuous thermal monitoring. We'll start the session shortly once everyone's joined. The previous webinar, I might add, Managing Temperature at Low Load, was incredibly popular and almost 200 people took in the learning from that. So we're expecting similar today. So we're just going to give people a few moments to join. I can see them in the lobby. It's really amazing to see how popular CTM has become. And you're all in great company. So the community is growing. Thank you for joining. This event is timed primarily at the APAC and EMEA regions, but there's another one later for the Americas. But wherever you are, it doesn't matter. You're all welcome. So, as I say, we can see the numbers increasing, so we'll just give folks a minute to come in. Whilst we wait, we've got a quick question for you all, just to give a sense of who's in the audience today. So I'll launch that while we're waiting. There we go. So please do participate in these. All responses are invisible to others and anonymous to us, and as always, we ask questions throughout the session. We really like your questions because they force us to think more broadly. But the audience can't see who's asking. So use the chat function in the top of your screen there to ask, and do that throughout. And we'll get to the questions at the end of the session in the Q&A and try and respond to all of those. And if we can't respond, we'll come back to you afterwards. We compile them all in a document, which is really useful for anybody that wants to know more about the topic, and we'll share that back with you along with the video via email. So today's session is going to take about 40-45 minutes, and then we'll have time for Q&A at the end. We'll record it and then send it to you afterwards, as I say. During the course of today's session, we're going to discuss various standards and codes, and you'll hear the term best practices and other similar phrases. The aim is not to promote any one particular standard or code, but to remain impartial, but just to give an informal view across all of them. So as I say, some notes on interaction. Please do participate, don't be shy, there's no stupid questions. Use the chat function and get in early. We'll prompt you throughout for the poll questions as they come up. Right. That I think is about it. I think we've got a good, healthy number of numbers. So I'm going to hand you over to two people who will be familiar with you now. John Hope, Extherm CTO, and Tulsi Patel, our Technical Operations and Support Manager. They'll guide you through today's session. So without further delay, John, Tulsi, over to you guys.
Thank you. Thank you very much, David. So good morning, good afternoon, and good evening, everyone. I welcome you all to the third and our final webinar session for the year 2025. So we truly appreciate your participation and the time we've all taken out to be with us here today. This webinar is titled Industry Standards and Best Practices for Continuous Thermal Monitoring. Now, the sole purpose of today's session is to provide you all with the valuable insight into how continuous thermal monitoring, CTM, is shaping the future of electrical maintenance. So together, we will explore the evolution of standards that have influenced industry practices and also examine how leading organizations are moving towards a more predictive, data-driven approach to asset management. As David said earlier, please note that this session provides only an initial overview of industry trends and recent standard updates, and this will help participants to prepare for discussion with subject matter experts, or they can study further. My name is Tulsi Patel, and I'm responsible for technical operations and customer support at Exeter. I work closely with John Hope, our CTO. Now, John's expertise in CTM has driven Exeter's progress in thermal monitoring. His strategic leadership has advanced our CTM solutions globally, and his insight today will be central to today's topic. John will join me as a co-presenter for this webinar, and I would like to appreciate his time and extend a very warm welcome to him.
Thank you.
So before we begin, let's look at a set of guidelines that allow us to run a smooth flow of the webinar. At the top right-hand corner of your screen, you will be seeing a question box icon. Now, during the webinar, all participants will remain muted. So if you have any questions, comments, or feedback, please use this designated question box to drop them in, and we'll pick this up during the dedicated Q&A session at the end of the event. Kindly refrain from using the chat function for this purpose. Now, during the webinar, you will see some more poll questions pop up that are relevant to today's topic, and we encourage all of you to join in and share your opinions because your feedback helps us make this event more successful. Now, I'll give a quick overview of the agenda for today. We will begin with a quick recap of the previous webinar and then follow it on by the introduction to today's subject matter. Our focus will then shift into the importance of thermal monitoring and the advancement in the technology related to it. We will also examine the challenges associated with the current method of biothermography before we delve into the ANSI meter standards. Additionally, we will explore the industry transition to CBM, condition-based monitoring, and we'll review the IC 61439 standard along with the IEEE P2969 guide. We will look into the best practices and specification standard, for example, the JIP 33. We will conclude with an overview of the NFPA 70B standard and open the floor to questions at the end of the session. However, please feel free to submit any questions you may have during the webinar in the question box. In our previous webinar titled How to Detect Compromised Connection Under Low Load, we highlighted the importance of considering load for an enhanced continuous thermal monitoring approach. Now, normally under heavy load condition, faulty electrical connections tend to produce noticeable heat, making them easier to spot. But in low load situation, identifying this compromised connection become more difficult due to the minimal heat they generate. Now, this can often hide the issue until it develops into a serious hazard. Additionally, early detection of faults in low load condition is also very challenging with IR thermography because it typically requires a load of 40% or more to be effective. Now, to overcome this problem, Exotherm provides a load map software. This software utilizes the delta T temperature and load data to calculate warning alarm thresholds for connections being monitored. Now, the load data can be entered either manually or dynamically through a metering device. The software can also help you determine the maximum load that you can safely apply to a circuit and also the remaining load that can be applied to. Now, this particular slide outlines the advantages of low load monitoring and emphasizes the significance of load for an improved CTM approach. Now, this practice can help you enhance your load capacity and redundancy planning. It ensures that critical circuits are free from compromised joint, which ultimately boosts operational uptime and minimizes downtime cost. Additionally, it promotes greater safety for personnel and it strengthens the asset management practices. Now, you can access recording of this webinar from our Exotherm YouTube channel, given the link on the slide below. Now, moving on with today's topic, let's first understand the basics, what the actual problem is, how it starts, and the issues with current approach. Now, as we all know, compromised electrical joints and termination are the most common cause of electrical failures and arc flash incidents. This can occur within the switchboard due to a number of reasons, for example, thermal expansion, contraction, loose connections, unbalanced load, vibration, overload at circuit, mechanical wear and stress, and harmonics. Now, periodic thermal imaging using infrared cameras has over the last 2 decades been the accepted practice for detecting compromised connection. However, this approach has several drawbacks, including infrequent inspection, which limit the likelihood of detecting issues, potential risk to personal safety, and challenges in identifying fault at low loads, lack of real-time data integration, and constraint related to line of sight. Looking at the current market insight and the new best practices, industries globally have started prioritizing predictive maintenance over periodic, and the demand for CBM, condition-based monitoring, is now greater than ever. Now, the shift has also led to the heightened demand for CTM, continuous thermal monitoring system, and this is further fueled by the digitization and the industrial Internet of Things, which emphasizes connecting temperature sensors, allowing for 24/7 data collection and analysis. This evolution in maintenance practice not only mitigates risk, but also ensures that potential issues are identified and addressed before they escalate into more significant problems. Now, to begin our discussion today, let's first look at the ANSI standard. In today's industrial landscape, electrical systems serve as the backbone, powering everything from manufacturing processes to essential facilities. However, the inborn complexity of this system can often hide problems that can lead to severe failures. Now, this is where the power of thermographic surveys, guided by standards established by ANSI NITA, become very crucial for maintaining safety, reliability, and uninterrupted operation. The International Electrical Testing Association, NITA, specifically through its maintenance testing specification, the MTS, and the acceptance testing specification, ATS, provide the gold standard for electrical testing and maintenance. Now, NITA's guideline prioritize predictive maintenance strategies, with IR thermography being a key crucial component. Now, by following this standard, organizations ensure that thermographic surveys are performed systematically by qualified personnel using calibrated equipment and is interpreted accurately. Now, the true power of a thermographic survey lies not just in identifying a hotspot, but in the intelligent interpretation of the thermal abnormalities and the appropriate action to take thereafter. NITA standard establishes a framework which utilizes delta T temperature monitoring to assess the severity of these anomalies and inform the necessary responses. Delta T measures the temperature difference between 2 points within an equipment or connection and their surrounding environment, making it the internationally recognized method for infrared thermography. While specific thresholds can vary based on equipment type, load, and environmental condition, NITA-aligned guidelines categorize temperature rises and suggest action as shown in the table on this slide. Ultimately, ANSI NITA standard transformed the thermographic survey from a basic diagnostic tool into an essential part in electrical asset management strategy, and hence promoting the shift from reactive repairs to predictive maintenance approach. Now, historically, industrial maintenance has always relied on two main approaches. One is the reactive repair, which addresses issues after they happen, and the other is preventive maintenance, which involves scheduled servicing regardless of the condition of the equipment. Now, both methods can lead to excessive labor cost, expensive downtime, and operational inefficiencies. While traditional methods involve periodic manual inspection using thermal cameras, this practice only offered a snapshot in time, potentially missing critical faults in between the assessments. The industry is now pivoting decisively towards a far more superior approach. This is the proactive maintenance using CBM, condition-based monitoring. This paradigm shift relies on the continuous monitoring of asset health to identify issues at early stages, long before they end up in a functional failure. Now, it is within this framework that continuous thermal monitoring has emerged as an absolutely necessary tool. CTM is far more than a mere technology upgrade. It has turned maintenance from being a costly activity into a fundamentally strategic requirement that help organizations achieve operational excellence, and build greater resilience into their systems. Now, as industries increasingly adopt intelligent and data-driven monitoring systems, CTM will become not just a competitive edge, but a necessity for companies that want to meet standards, stay compliant, and keep operations secure. Now, before we move on, please take a moment and respond to our first poll question. So the question is, which statement best describes the current use of CTM, continuous thermal monitoring, in your organization? So please let us know what your current status is in the organization. This feedback is really valuable and it will help us better understand the level of CTM adoption and your journey towards enhanced safety. I think that was really good results. So 43% have said installed across all critical systems, 10% installed in selected areas, 8% planning to install during the next 12 months, and 40% still exploring options but not installed yet. So thank you to all that have responded. There are going to be a few more poll questions, so we really emphasize that you fill this in and give us your input. Moving on, now many electrical standards are often interconnected because they often reference or rely on guidelines from other recognized standard development organizations, such as those listed on this slide. Now, it's really important to recognize how these standards collectively shape best practices in electrical safety and maintenance. Each organization contributes a unique set of guidelines, but together they create a comprehensive framework that ensures the integrity of electrical system in various industries. I will now hand over to our CTO, John Hope, and he will lead the rest of the webinar and provide us with a brief overview of standards that leverage CTM and how organizations can help stay compliant. So over to you, John.
Okay, thank you, Tulsi. That was wonderful. Thank you for that start to the webinar. It was very, very, very insightful and interesting. So I think as David mentioned and as Tulsi's mentioned there, what we want to do here is we're not going to give a really deep dive into the standards, but this is a skim over the surface to look at the standards that are out there. There's the standards, there's guides, there's codes, there's recommendations, and just see how all these affect us in safety, in maintenance, in best practices. And again, as Tulsi mentioned, that as how they actually all intermingle and they all feed off each other. So the first one here, IEC 61439, it's quite a global standard. When we say global, it's mainly towards the, as it says, IEC region, so anything other than the USA, but it's still linked into that region. There are still references towards it. There's still other standards linked to this IEC standard, and its main objective really is to establish requirements for interchangeability, predictable behavior. It's all to do with the design, the builds, the switchgear itself. It also looks at safety of the personnel and equipment, but also heavily into the performance and also to verify that design in heat rise type testing. So it's a standard that is really aimed at this is how you should design and build your switchgear and how you should test it to prove it meets those standards. So as we're saying, it's got a big emphasis on temperature rise limits. How warm can a bus bar operator? How warm can a terminal be? How warm can the internal steel work? How warm can the external steel work be? So it really is looking at temperatures throughout the whole unit. And I think, as we all know, excess heat is the killer. That's what will kill either the components or the bus bars or cause problems. That's the big problem in any piece of switchgear, any electrical system: heat. Heat is not what we need. We have to get rid of that heat. And ultimately, it could cause a fire, an outage, major safety problems. So fundamentally, what IEC 61439 aims is to ensure that when an assembly, a piece of switchgear, is built to the specifications, to the standards laid down in that code, that it will operate safely within all those thermal boundaries that are laid down. Quickly going through this table, and I think as we've done with others, this presentation will be available for download at the end. So, you know, what we don't want to do is read everything word for word. You guys can all read this, or guys and girls, sorry, can all read this yourselves. We're looking over the top. So we're sustaining that design compliance. What the standards ask for is all assemblies are designed to operate within those specific temperature limits. Now, it's a snapshot. Yes, it's a design. It's a standard that's put to say your piece of switchgear will not go outside these temperature limits, be it the bus bar, the connection, the internal steel work, the external steel work, anywhere. But it's a snapshot. It's, yes, it complies. Yes, we've carried out a type test and it passed. But we have to remember that those type tests are in laboratory conditions. By using thermal monitoring, so by using CTM, you're able to continually verify that those assemblies actually remain within those approved temperature limits. Maximum heat rise or maximum temperature on a bus bar connection. Let's say in certain circumstances, it's 105 degrees C, could be 115 degrees C, depending on the bar type and the bolts used, etc., etc. How do you know that that piece of switchgear hasn't gone above there? You use CTM, you can verify this. So not only are you verifying we've got a healthy connection, we've not got a loose joint, but also that my switchgear has stayed within the standards. So you can also use it for verifying that design. Again, it stays within the standards all the time and allows the operator to even optimize the operation of that gear even further just by simply tracking temperature. What can I do to my ambient? What can I do to my external ambient or internal ambient to affect the other temperatures to actually operate my gear within those standards? Now, there's another one that's coming out at the moment, and it's been a project that's been ongoing for quite a while, the IEEE, the P2969. It's why it's got a P number, because it's still a project at the moment. And what the IEEE aims to do is provide a set of standards, so some mandatory requirements. It then also gives recommended practices. So what do subject matter experts, what do they recommend you should do? What do they recommend the design should be? What do they recommend you should put in there, or how you should carry out things? And then guides, which are just suggested approaches. Now, at the moment, the P2969 is in the guide stage. It was started in 2021 by the Standards Association, and actually has been quite a large body of people from all walks of life, from all industries, from different OEMs, different manufacturers, different equipment suppliers, different end users. So it's been a big amalgamation of thoughts and ideas to get to this point. And The project now is going through, I believe it's now approved. In fact, I think it is almost as in the last few days. That the P2969 Guide for Continuous Thermal Monitoring of Switchgear and Motor Control Centres below 52 kV. So it's coming out very shortly as a guide. What this does, it describes you the approach to CTM, how you should use CTM within switchgear, within power systems. And what the aim of this guide is there is to help, maybe not replace instantly, but it's helped to complement thermographic inspection. We all know thermographic surveys, inspection are carried out, but it's a snapshot. It's why, I think as we saw from that poll, I think was it 43% are saying they've already got some form of CTM on their critical systems, and others are looking to move forward with it. It's that continuous data. So this IEEE guide is there to help complement that traditional thermographic survey. Maybe one day it may get there. It may help to actually replace it. I don't think there will ever become a truly time where it's totally replaced, but let's hope for safety, for maintenance, we start to get there. The future outlook, IEEE want to make this as a standard practice. So not just a guide, but let's have it as a standard practice. And there's links to all this information and the guides at the end of this presentation, at the end of the webinar. There are links to all these so you can get a lot more information. So let's look at our third poll question. Let me just bring that up. Give me 1 second. So why are standards and compliance, why is it so important to you as an end user, as an engineer, as a consultant? Why is it important to you? So let's just give that a minute or so to run through.
And
Wow.
if you have any different answer, you can always put that under the question box, or if there is any further explanation to the options we've got here, we would love to hear from you. So yeah, please put feedback in the question box.
Yeah, no, very good. A good point to raise, Tulsa. Yeah, we try to think of the questions. We try to think of the answers. There could probably be another half a dozen answers that could go in here. So yes, if you have anything else, any other comments to make, throw it into those questions, and that's really useful for all. Well, this is fantastic. I think we'll stop it there because we're just over a minute in, and we've 62% of people have responded, which is absolutely fabulous. Yeah, at the moment we've got 8% of people are saying to improve maintenance practices. Absolutely. 73% to enhance safety and reliability. Absolutely. And I think that is where this is where all the standards are trying to drive, or it's where they've all been trying to drive at the moment, is enhancing that safety and reliability. So great results. Staying compliant to sell in the global market. Absolutely. If your switchgear isn't built to those standards, how can you work in that global market? If you can only operate locally, then what's the point? And 8%, yeah, interesting. Maintain insurance coverage. I think again that is becoming quite a strong message from insurance companies that yeah, you need to build to the standards. So thank you for completing that one. So let's move on now and look at best practices. I think over the years, many companies who are within the same sort of industry, either data center industry or oil and gas or shipping. They've all got together and created their own sort of best practices. It's been a very collaborative approach, and that has become, well, this is the best practice for this particular industry, because again, those practices can be different depending on what the industry, depending on what the location. It's going to be different from, slightly different from what's required in marine to, say, oil and gas to what's in a data center. They're totally different industries. And this collaborative approach has led to development of a set of specifications that become the building blocks, become that foundation for best practices within the industry. And all these people have shared their knowledge and built this framework. And some examples have been PIP, so the Process Industry Practices, and the JIP, the Joint Industry Practice. Now, if we look at the JIP and JIP, can't even speak today, JIP 33, where that came from, so the context of how this came about was, we can see from here, between 2010 to 2014, what they said was that 75% of large E&P projects exceeded budget by 50%. Who would have thought? That's a huge exceeded budget. And that was an average figure. So obviously some were a lot higher, some were lower, but that's an average figure. And 50% of those projects exceeded the schedule. So way, way over schedule. So the objective and the vision was, something has to be done here. We have to resolve these issues. Why is every project working to a different standard, a different set of specifications, trying to build it different? So in 2018, along with the World Economic Forum, or their encouragement, it facilitated the creation of the JIP, and it became the JIP 33. And that was put in place to try and remedy that situation and create, these are standard specifications. These are the standard guides of how you should put those projects together. This is what you should be doing from day one. And the framework consisted of 14 standing committees, and they were devoted to this development and sharing good practices. Now, yes, it's obviously to do with the oil and gas industry, is JIP 33, but it highlights how some of these standards, how some of these guides have been put together and why. We have one here, IOGPS 732, as its number is, and that's for low voltage motor control centers. Extra clauses were added into that specification that were never there before to add continuous thermal monitoring. And as we can see from the clauses on the screen here, if I just put my laser, there we go, continuous thermal monitoring, if it's specified, then it shall be in accordance with the 3 clauses below. Shall be equipped with a factory integrated CTM technology. It shall provide hotspot detection sensors for main incoming sections, main circuit breakers or lugs, and other areas of concern, such as individual units or shipping split connections. Shall include fault relay, dry contact output, and communications. So they've been quite prescriptive in what you should put in there without naming suppliers, but it's no, you should start to put CTM in there. It really should be included. S620 supplementary spec for high voltage switchgear and control gear. Again, it puts up condition monitoring. It shall be integral to the assembly. It shall be real-time continuous monitoring. And I think this is quite an important point here. Any sensors that you install should be maintenance-free for at least 5 years, and even longer if possible. You want to fit these sensors that have got reliability. Your data shall be displayed on an HMI. Yes, there's no point having data that you can't see. It does mention actual thermal monitoring, busbar joints, circuit breakers, busbar connections, cable terminations, as a minimum, be monitored. So again, this is an extra onto that JIP 33. You should start using condition monitoring. The standards are starting to push. You should start to put this in, start to put the monitoring in there. There's also a supplement which sits alongside the IEC 61439, the S560. And again, that starts to specify use condition-based monitoring. If you're going to do it, it should provide real time. It should have a communications interface. You should be able to view that data locally. And if it's thermal monitoring that's been put in now, if it's specified, they shall be equipped with factory integrated CTM technologies. And again, it's hotspot sensors, main circuit breakers or lugs. So yes, it doesn't quite go into as much detail as some of the others of exactly where you should place it, but this is now the supplement to IEC 61439. You should start looking at putting in condition-based monitoring. This is how you should do it. This is how it should be prescribed. So it's that now best practice all coming together and giving that standard of what should be done. NFPA. Now I know that's mainly in sort of the ANSI region, but NFPA is starting to be recognised. They're starting to be heard of in all other areas of the globe. There are 3 parts to it. There's the NFPA 70 NEC, so the National Electrical Code. When it's the code, it's the law. You have to do what it says in that code. I think all of these standards, they make interesting bedtime reading, especially if you've got a bit of insomnia, but it's the code. It's what people should be working to. There's then NFPA 70E, which feeds into that NEC code, which is mainly addressed at the safety. It's the electrical safety of personnel or equipment. There's also 70B, which feeds into those other 2, and that focuses on maintenance, how the equipment is maintained. But all these again can all feed into that maintenance, all feed into the specifications. If we look at NFPA 70E 2024, there was a new reference, an Annex S, which is linked to the safety stroke maintenance. So again, this is where all these 3, all the 3 codes, they have that interoperability. They mix, they have links to each other. And we'll come on to a little bit more detail of that in a second. NFPA 70B, some of the language has changed. There's been a shift from the word recommendation to standard. So making things starting to become mandatory. You will do this. Rather than we recommend you to do something, it's you will do this now. And 70B is all around maintenance intervals, environmental conditions, condition of the maintenance, what's physically happening within there. So Annex S, the NFPA 70E, really it's informative, and it's providing guidance to assist those qualified people, the workers, someone who's going in to actually carry out the work, those electrical engineers, electricians, and it's helping them identify information that's useful when assessing the condition of the maintenance of that equipment. If we just very quickly look at the paragraph on the left, electrical safety programs contain requirements to consider the condition of maintenance of electrical equipment and systems. Now, the objective of that is to emphasize that risk, or the inherent risk, to the workers who could be going to carry out some work on that equipment. So it's associated with those tasks on the equipment that might not be properly rated, may not be properly installed or maintained. So it's there to enhance that safety of the personnel. The annex also discusses methods for determining the condition of the maintenance. Well, how well is it being maintained? What else should you do? Is it just visual inspection? Is it taking voltage readings or ultrasound or partial discharge? It starts bringing in infrared thermography. Now, carry out thermography. Start using condition-based monitoring so you know the health of that asset. You know, is it safe? Is it healthy? Is it in good condition? And, you know, these are becoming best practices now within that. NFPA 70B, it's the standard for electrical equipment maintenance. And as I mentioned a couple of slides ago, it's now transitioning from the word recommended to being enforceable standard practice. It's trying to give mandatory maintenance intervals based on the equipment's condition. You assess the condition, and these are the maintenance intervals you should now stick to, be it 6 monthly, 3 monthly, 12 monthly, every 2 years. But depending on the health, these are the intervals you must now stick to. In the 2023 edition of NFPA 70B, 2 clauses, 9.111, 9.112. And what they say is continuous monitoring or predictive techniques shall be permitted to be used as a consideration when determining maintenance intervals. So it's not just up to the individual saying, yes, we've maintained it, it's in good condition, it looks healthy, there's no problems, we'll maintain it every 12 months or we'll maintain it every 2 years. Tick the box, away we go. My book says this is what I should do. Happy days. This is now saying you should use continuous monitoring. They can be permitted to tell you what's happening inside that equipment. Is it actually healthy? Is it in good condition? And then determine, oh, I can move from 6 monthly maintenance actually to every 12 months now because I know the health. But also continuous monitoring, all those predictive techniques shall be based on manufacturers' recommendations or accepted industry practices. So again, it's starting to bring all these other standards, all these other guides, they're all linking together. NFPA 70B says this, but manufacturers' recommendations or accepted industry practice, JIP, IEEE, they're all linked. The 2023 version of NFPA 70B this is a word, and this is an extract from there. And this just talks about using infrared thermographic inspection. And it shall be performed as laid down here. I'll not go through them one by one, but it shall be used when required to verify temperature differences. So delta T, and delta T, this is what our sensors give you, delta T. It's that important measurement. Similar electrical components under similar loading. Comparison between electrical components and ambient air temperatures, but it's internal ambient. It's internal, not external. That's the IC 61439 for heat rise. That's not what this is looking at. This is looking at the health. So this is what it says. You can use infrared thermography. It mentions nothing about condition-based monitoring. This is the 2023. 2026, there's a new version, new edition coming out. It's in second draft at the moment. I believe that all comments, where we're saying down in the bottom corner there, it's been posted, all comments have closed, and I believe it's due to be released officially end of this month, I think. Now, that same section, infrared thermography, has changed. And it now says, or saying to a point, but then 7.4.5, continuously monitoring permanently installed temperature measurement devices shall be permitted to satisfy 741 to 744. So now you don't have to do that thermography. You can use condition-based monitoring. Put thermal monitoring in there to satisfy all these points. 7212 says permanently mounted sensors shall be permitted to monitor the temperature of electrical connections and terminations. So now you can know the quality of those bolted connections by any of these methods, either thermographic inspection or by putting condition-based monitoring. So this is the change. This is where all the standards are starting to move towards. A simple question: how can Exotherm help to keep NFPA 70B compliancy, or with any of the others that specify you can use condition-based monitoring? We provide a single patented sensor. It measures that delta T. It's what the standard asks for. The certified lifetime calibration requires no maintenance. Remember from a previous slide where I think it was a JIP said shall be at least 5 years and not require maintenance. So this is what you need to look at when choosing a system: is certified reliability. Has it got comms? Guarantees. Let's look into poll question 4. So I notice the time is racing away with us today. I think we're all enjoying it too much. So this poll really is: what's your biggest challenge in ensuring compliance with the current maintenance standards? Is it keeping up with those updates and revisions? Is it the physical cost? Is it because it's costing so much, it's an issue? Training. How do you get your personnel trained? How do you get trained? What are these standards? Or difficulty in actually trying to retrofit a solution to help you get that condition-based monitoring. And we'll just give this another few seconds. So 19% are saying it's keeping up with those frequent updates and revisions. Yeah, totally understand. It's always an issue with everything, trying to keep up to date. Cost, 90% are saying it's the cost of doing it. I think it's one of the, it's that double-edged sword. It's the cost of keeping up, but also what's the cost of not keeping up to it. But yeah, no, valid answers. Training, trying to get people trained, 26%. Interesting, 37% have said difficulty in retrofitting a new solution into existing or old switchgear. So yeah, very good, really good. Oh, come on, go forward, thank you. Okay, we're coming to the last couple of slides now, and then we can hand over to one or two questions, and any others we don't get to, we will respond and they're available for download we can send. But to conclude this, compliance is safety. I know we mentioned a lot about safety, maintenance standards. Well, all these industry standards and guides, be it ANSI, NETA, IC, IEEE, NFPA, they're all there to increase the safety, the design of the equipment, but also the maintenance processes that you can improve to identify and resolve problems before they become failures, before you get that loose bolt which eventually causes, you know, an arc flash and an outage. These practices are here to try and prevent that from happening, and they're evolving. They're evolving all the time. By incorporating exotherm, by putting our CTM solution in, you're getting that real-time monitoring, which when we look back at all those previous slides on all these, you know, IEEE, NFPA, JIP, it's all about real-time monitoring of those critical connections, giving you that data so that you can carry out informed decisions. You know the health of the equipment. Optimize your performance. Go back to the temperature rise limits. You know what that piece of switchgear should operate within. Use CTM to enable you to optimize that performance, stay within those limits, and elevate the safety and reliability and efficiency of that gear. Now, moving forwards, everybody embraces these. It helps to build that robust, dependable structure that we can all rely on. It's got collaboration on best practices between industries and within an industry. But to be able to do that, people need to adopt CTM. Now, we mentioned the references. Here's some links to all the documents so you can have a read of more, you know, in a lot more detail than we've obviously covered today. It's a very, very brief look over the system. I know I've only got 3 or 4 minutes left now. Questions, anybody got any questions we can go through? As we said, if we don't get to cover it now, we will answer those questions and they'll be available. We can send them out to everybody. They're totally anonymous, so nobody knows who asked what. It's just there's a question and there's an answer.
Great session, guys. We're really conscious we've got just a few minutes left, and there's a bunch of questions floating around. Perhaps the first one we'll tackle is NFPA and the as an American standard. There's a few questions about, how does this apply to, EU, for example, or Europe or other regions? Is it a transferable standard? How widely is it adopted? Or is there a market or industry that, kind of essentially follows NFPA? Very, very broad.
Yeah, and it's a very broad, in a way, it's a difficult question to answer, but yes, it's an American standard, it's a USA standard. But from what we're seeing, more and more regions, more and more people are starting to adopt what is in that NFPA 70B or refer back to it at some point. So yes, it's not a standard that is generally used within the IEC world, but they all start referencing back to, oh, as in the NFPA, as in this. So all these standards do start interlinking, and I can see at some point that, yeah, the standard could come across and start being incorporated quite heavily into European and rest of world standards.
Good. We've got all sorts of questions coming in now. Yes, we can share the presentation afterwards. We will do that. And I see people are asking for specific paragraphs and things like that. Perhaps my suggestion is, perhaps if you've got specific questions or you need advice or guidance from anybody on the Exotherm team specifically to your organisation, reach out to us, and we can, you know, one of our team will come back to you on any specific topics. I'm conscious we've only got a few minutes left. There was one particularly interesting question that came in around sometimes customers looking at a way to overload an installation above rated current, for example, lowering the ambient temperature. Therefore, continuous temperature measurement becomes mandatory. Do you have a reference project or know where or an example of how this might be done? Or is this against standards?
Good question, and yes, quite right. What you're saying here. Yes, some customers do. You know, you do want to run at overload, you know, conditions for whatever reason. Without naming the project, shall we say, it was a large oil and gas project in Kazakhstan, and I think for those in the know, they'll know where that was or what it was. But that was one of the reasons why they installed CTM in over 200 substations throughout the project, was not only to tell them what was the health of the system at a given point, but also by incorporating our load map algorithms and software that we covered in the last webinar, was to really give them a true health to say, you know what, we need to take a substation offline. Can we run another piece of equipment in that overload condition and know the health is good? Or what do we need to do to our switch room ambient to be able to run it in that overload condition and be able to monitor it and know that it's running safe? So yes, I think the answer there is that sometimes customers are looking to run in that overload condition without having some form of CTM. You don't know what the health of the board is before you go to that condition or during that overload condition. Is it still healthy? Are we still okay? Or are we pushing the envelope too far?
Yeah. We're up on time. Unfortunately, there's so much information in there. We're out of time, so we're going to have to wrap it, guys. But like John said, we will get back to you all with responses to all the questions asked here. And don't stop there. You know, as I say, reach out if you have more. And also let us know if you've got ideas or themes for next year's webinar series. We'll tackle any topic in the CTM field, so let us know. John, Tulsi, wonderful session. Thank you, guys.
Well, yeah, I'd just like to say thank you to everybody who's given up your time. I know it's very precious. Wherever you are on the globe, thank you so much for giving up an hour and attending this session. I hope it's been useful. As David says, you've got our details. Any other questions, send them on. So, and
just quickly before we go, there'll be a follow-up email after this where we're running the CTM survey. We would love to hear your responses. Again, they're completely anonymous, takes less than, I think, probably somewhere between 60 and 120 seconds to complete, so really easy to do. So we'd welcome your input there, guys.
And just again, as another one, we just forgot about that one, is would you like to receive that Q&A document after this session? So we know not everybody wants all bombarding with links and documents and everything. So yes, if people would like responses and how we responded to some of the questions, let us know, and more than happy we'll send them. And those that say no, you won't receive it. Not a problem. We'll just give that a minute while you're all dropping off, and then thank you and enjoy the rest of your day.
Thanks, everyone.
I think we're slowing down. 100% of people voted. Right. Thank you, folks. All have a great day.